Let's discuss question number 29 from test 1. You have a beam again, a cantilever beam given. Let me redraw it. But instead of a UDL, now you have a triangle load, something like this, where the maximum intensity of the load is given as 300 kilonewton per meter, and this is acting only on the some portion of the beam, that is 900 mm, and then you have the empty portion which is 400 mm. So this is your point A. Okay, now what we need to find out is the maximum bending moment. Obviously the maximum bending moment in a cantilever beam, unless the load acts upwards, maximum moment is at the built end. Okay, so first what we do is we replace this triangle load with the equivalent concentrated load, and the way a triangle load is replaced. So let me draw a triangle. The way a triangle load is replaced, it is replaced at, so if this is my L, so at 2/3 of the L I put a equivalent load, and the value of equivalent load is, if the maximum intensity is W, it's basically area of this triangle, so half WL. So let's replace. So this is how you replace a distributed load with the equivalent load, and the position at which you want to replace, or the value at which you want to replace, will get from the equivalent distributed load analysis, which we do in mechanics. So that's another area, but let's replace this triangle load. Okay, so this is the point at which the triangle load starts. From here, 2/3 of L is 900 here, so 2/3 of L, which is 2/3 of 900, which is 600 mm, and this is my given 400 mm. The total is 900, so this is 1/3, which is 300 mm. Okay, now the value is half W is 300, L is 900, this is 3 kilonewton per mm, so this comes out to be 450, or yeah, so this is 13500, or 27 by 2, which is 13500. Okay, so kilonewtons. Okay, so this is the load. Now it produces maximum bending moment at point A. So the moment that is produced by this load is basically that load into the distance from A. Okay, and that distance, so this is the moment produced by P. So when you want to find out bending moment at this cross section, so all the loads right side of that will play a role. So load is 13500 into the distance is 400 plus 600, so that is 13500, basically 1000 mm, and this was kilonewton. So this I can write as 1 meter, so 13500 kilonewton meter. So this is the maximum bending moment which is produced. Obviously this load, further the distance, because the load value is same, so that will be the location where maximum moment is produced, and further distance is at A, so A is the location where maximum bending moment is produced by this. Okay, so the option is B. Thank you.